Dear students, in this video we will solve integration questions using substitution method. As we were doing in differentiation also, what we used to do in differentiation, that some part of the function which we are differentiating, we use to substitute as some new variable. We generally used to call it t. Same technique we will try in integration also. Whatever function we are trying to integrate, some part of the function we will substitute by some other variable, and then we will see what happens. So let us integrate using substitution. I have written a question here. Integral of x square root of 2x plus 1 dx using substitution. Let us solve this question. Let us put t equal to 2x plus 1. So we are going to substitute t in place of 2x plus 1. Now if we observe, t is a function of x. So this gives us the liberty of differentiating t with respect to x. So when we differentiate with respect to x, this will give us 2, derivative of x will be 1, plus derivative of 1 will be 0. So this is equal to 2. This implies that dt by dx is equal to 2, and this implies that dt can be written as 2 times dx, or we can say that dt by 2 is equal to dx. So now if we see the original integral, that is integral of x square root 2x plus 1 dx, this can be written as integral x square root of 2x plus 1, you have put 2x plus 1 is equal to t, so it becomes square root of t, dx you have already calculated, dx is equal to dt by 2. So our original integral has changed this form now, but still if you see, we have 1x appearing in this integral, which still we need to change. So if we observe our substitution, we used t is equal to 2x plus 1. This expression we will use to find x in terms of t. So this gives us t minus 1 is equal to 2x, and this gives us that t minus 1 divided by 2 is equal to x. This expression we will substitute here, and the integral now becomes integral x, that is t minus 1 by 2 multiplied by root t dt by 2. And this gives us integral t multiplied by root t minus 1 multiplied by root t, that will be root t, divided by 2 multiplied by 2, that is 4 dt. We can further simplify it. Integral t and square root t can be written as t power half minus square root t can be written as t power half dt divided by 4. Or we can write it as integral of t power 1 t power half. So the powers will add. That will give us t power 3 by 2 minus t power half divided by 4 dt. And now using the formula which we have already discussed, integral of x power n dx is equal to x power n plus 1 over n plus 1. Using that formula we get 1 by 4, this 4 we can keep it outside the bracket, and t power 3 by 2 gives us t power 5 by 2 divided by 5 by 2. So 2 we can keep in the numerator, minus t power half will give us t power 3 by 2 divided by 3, and 2 we can keep in the numerator. And now we can put back the value of t, that is t is equal to 2x plus 1. So that will give us 2 t power 5 by 2, that is 2x plus 1 power 5 by 2 divided by 4 multiplied by 5, that will be 20. Second part, that is minus 2 t power 3 by 2, that is 2x plus 1 power 3 by 2 divided by 4 multiplied by 3, that will be 12, plus constant of integration c. This is our final answer.